We now move on to the next question. June 2016, paper 2, question 8. Find the set of values of x for which x plus 2 on x minus 1 is strictly less than 3. Many students will make a lot of mistakes with questions like this. For you to solve this inequality, you have to bring everything to the left-hand side and simplify. Therefore, you have x plus 2 on x minus 1 less than 3 to become x plus 2 on x minus 1 minus 3 to be less than 0. We look for the LCM and we simplify, and we obtain the results minus 2x plus 5 all on x minus 1 to be strictly less than 0. On the number line, you can do the testing or you can make a table, and with this table the only region that satisfies are the regions above 5 on 2 and the region below 1. So in the form of intervals, you can write the interval as follows: from minus infinity to 1 from below, and from 5 on 2 above to positive infinity. Or you can use the normal notation: x is strictly less than 1 union x is strictly greater than 5 on 2. Now we are given this function and we are being asked to look for the range of the function. Note, the range of a function is the domain of its inverse. So we just have to look for the inverse function and obtain the domain. Or we make x the subject of the formula and solve for the domain using y. So in this case, you have 3x minus 4 to be equal to x plus 2 times y. Making x the subject of the formula, we will obtain x to be equal to 2y plus 4, all that on 3 minus y. And this function which is in terms of x now is the inverse function, is defined when y is not equal to 3. And the range of the function is a set of all real numbers excluding the value 3. That is the domain of this function. Don't forget to click on the subscription button, and don't forget to share our videos, for many will be coming after this one, question 9 and others. We now move to the B part of the equation, which states x. Now to sketch this graph, we first start by looking at the domain of definition. Equating the denominator to 0, the domain is already there actually. The domain is a set of all real numbers excluding minus 2. So when you look at the domain in the form of intervals, we have 4 bounds. We have to look for limits at each of these boundaries of the domain of the definition. But it is easy for us to combine negative infinity and positive infinity for this particular function, since we know that we will obtain the same value. The limit as n tends to negative 2 from below is positive infinity, and as x tends to negative 2 from above is negative infinity. This therefore tells us that the value x equals 2 is an asymptotic line, and in this case a vertical asymptote. You can see this from the domain of definition. Minus 2 is excluded from below and from above. The next thing is to state the asymptotes, and here we have the vertical asymptote from the domain of definition to be x equals 2, and the horizontal asymptote from the limits as x tends to positive or negative infinity to be equal to 3. Therefore, the center of symmetry, though it has not been asked, can be given by the vertical asymptote, comma, the horizontal asymptote, and in this case, minus 2, 3 is the point of symmetry. The next thing is the intercepts, where the curve cuts the coordinate axis. When x equals 0 in the equation, y is minus 2. So we have an intercept at A. Then when y is equal to 0, x equals 4 on 3. We have another intercept at 4 on 3, 0. The next thing, we look for the derivative function. And looking at this derivative and simplifying using bottom the top minus top the bottom all on bottom squared, as some students you say buttocks the top minus top the buttocks and so on. I don't know, it's a mnemonic, I'm just using it. It's crazy, but it's funny when I'm teaching in class and they use it. So when you simplify, we have y prime to equal to 10 all on x plus 2 squared. Looking at the numerator of the derivative, there is no variable in it. This tells us that there is no turning point. And since the numerator is positive and the denominator is positive, it means the derivative of the function is strictly greater than 0. Therefore, the function is strictly increasing. We can now move on to our curve. Those are the coordinate axes. We put a horizontal asymptote x, y equals 3, and a vertical asymptote x equals minus 2. Then we sketch the curve passing through the intercepts which we mentioned above, and since the curve is symmetrical about the point minus 2, 3, it therefore means it equally exists on the other side of the curve, and this is how the curve is to be sketched. Thank you so much for your kind attention, and we hope that this will help you to have better grades in your studies and actually find a positivism in your charism which you pursue in life. Thank you so much. Bye. Don't forget to subscribe and share our videos. GCE Maths Panel.